Good morning, all of you. In today's lecture, we are going to derive Nernst equation, which can be used to determine the electrical potential of single electrode, and it is known as single electrode. The equation which can be used for single electrode potential. Yesterday, all of us studied the Nernst equation, which can be used for EMF of the complete cell. I will repeat it once again. So for this, once again we can consider Daniell cell, Daniell electrochemical cell. In Daniell cell, the negative electrode consists the zinc electrode dipped in zinc sulfate solution. If we dip the zinc in zinc sulfate solution, immediately this reaction takes place. Zn get converted into Zn2 plus with loss of n 2 electrons. Because of this chemical reaction, here potential is developed. On this electrode, potential is developed. And this potential is called as the single electrode potential or half cell potential. Whenever you can be in zinc sulfate, then this arrangement is called as half cell or single electrode. Why? It is because of this half cell reaction takes place, and here potential in this on the zinc electrode, zinc metallic rod, potential is developed, and this potential is called as single electrode potential. And in Daniell cell, here this zinc electrode acquires the negative charge, and this is called as negative electrode, or this is known as the anode. This electrode is known as anode. So negative electrode or anode is nothing but the electrode at which the negative potential is developed. The anode and negative electrode means, in other words, we can say that this anode or negative electrode means whereas oxidation reaction takes place. Anode or negative electrode means whereas ions are formed. Ions are formed means zinc metal get converted into Zn2 plus. So negative electrode means we can define the negative electrode or anode in an electrochemical cell in three ways. The first, the electrode at which negative potential is developed. Second, the negative electrode means whereas oxidation reaction takes place. The negative electrode means whereas ions are formed. Okay? So this is the oxidation reaction takes place in Daniell cell at the negative electrode. Zn get converted into Zn2 plus with loss of 2 electrons. Another electrode is the positive electrode, which consists copper can be dipped in copper sulfate solution. Copper rod can be dipped in copper sulfate solution. So immediately this reaction takes place. Copper 2 plus twice of P minus gives rise to Cu. So this reduction reaction can be takes place here, and because of this half cell reaction or because of this half cell reaction, here potential is developed, and this copper metal acquires the positive charge. So this is this single electrode is known as cathode. It is known as the cathode. So positive electrode or cathode means whereas which has the positive potential, or cathode or positive electrode means whereas reduction reaction takes place, or the ions are get discharged. Means in an electrochemical cell, positive electrode or the cathode can be explained in three ways. How? The first, the positive electron means which has positive potential. This is the first definition. Second definition is that this is the positive electrode or cathode means whereas the reduction reaction takes place. And third, this is the electrode at which ions are get discharged. Means copper 2 plus ions accept the electron and it will get neutralized or get discharged. So this is the positive electrode whereas ions are get discharged. Ions are get neutralized. All of it. So we see here. I will repeat it once again. The negative electrode means which has negative potential. Ions are formed or whereas oxidation reaction takes place. Positive electrode means whereas which has the positive potential whereas reduction reaction takes place or ions are get discharged. Okay. So these are the two half cells. And these two half cells combines with the help of solid pitch. Externally by metallic wire. And here the EMF is produced. So we see here oxidation takes place. Oxidation at left. That is Zn get converted into Zn2 plus twice of E minus. On the left hand side, oxidation reaction takes place. On the right hand side, reduction takes place. Reduction at right. Reduction at right. Cu2 plus twice of E minus gives rise to Cu. An overall reaction or same reaction. Same reaction. This twice of E minus get cancelled. Zn plus Cu2 plus gives rise to Zn2 plus Cu. So this is the cell reaction. So this is about the Daniell cell. That is half cell reaction and cell reaction. And EMF of the complete cell is given by the equation AC is equal to reduction potential of right hand side electrode, reduction potential of this right hand side electrode, minus reduction potential of left hand side electrode, reduction potential of this left hand side electrode. So ER means reduction potential of right hand side electrode, EL means reduction potential of left hand side. And in the previous lecture, all of us studied the derivation of Nernst equation, and this Nernst equation can be used to determine EMF of the complete cell. So according to Nernst equation, EMF of the complete cell is given by EC is equal to E0C minus 2.303 RB divided by NF log of QA to the base 10. In this equation, E0C is nothing but standard EMF of the cell, standard EMF of the cell. R is gas constant, R is nothing but gas constant, that is equal to 8.314 joule per Kelvin per mole. T, that is the temperature. F, Faraday, that is 1 Faraday is equal to 96500 Coulomb. N is nothing but number of electrons involved in a chemical reaction. In Daniell cell, number of electrons involved is equal to 2. All of it. So we see here, this is the Nernst equation. And QA, last, QA is nothing but reaction quotient. Reaction quotient. And this QA for the Daniell cell, this QA reaction quotient we can write from the same reaction. So for Daniell cell, this reaction quotient is equal to activity of the product of activity of the product, activity of Zn2 plus multiplied by activity of Cu divided by product of activity of Zn multiplied by activity of Cu2 plus. And activity of Cu, that is pure metal, and activity of Zn is equal to 1. So Qa is equal to activity of Zn2 plus divided by activity of Cu2 plus. So reaction quotient is given by this equation. So reaction QA, how we can determine how we can write the reaction quotient? So reaction quotient can be write according to the cell reaction or according to the reaction. That is equal to the product of activity, product of activity, and the activity of the first we can write the product of activity of the product Zn2 plus and Cu. So activity of Zn2 multiplied by activity of Cu divided by product of activity of Zn and activity of Cu2 plus. All of clear? So this is the Nernst equation, and which can be used to determine the EMF of the complete cell. Means this here, because of this cell reaction, EMF of the complete cell is produced, and this EC can be determined by using Nernst equation. All of clear? So similarly, we are going to derive the Nernst equation, which can be used for the determine EMF of single electrode. Means this here, whenever we can deal the Zn in zinc sulfate, Zn in zinc sulfate, Zn in zinc sulfate. So Zn get converted into Zn2 plus with loss of an electron, and here potential is developed. So this potential is called as half cell potential or single electrode potential. When we deal in copper sulfate, so here immediately this reaction takes place, reduction reaction. Copper 2 plus twice of P minus gives rise to, and because of this half cell reaction or because of this reaction, here potential is developed. This potential is called as half cell potential. This potential is called as single electrode potential. So the potential of single electrode can be determined with the help of Nernst equation. So this equation we are going to derive. So the derivation of Nernst equation, which can be used for single electrode, this derivation I will explain in next lecture.